Hi all, welcome to the 12th and the final part in the series on how to create your own text editor in Go programming language. So just like in the previous video, I'm not going to be writing any line of code today, but instead I'll walk through those lines I've added already since the last version, just to make sure that I don't make any annoying typos and you will not be watching me typing this forever, because otherwise it takes another, I don't know, 50 videos to accomplish the series. So I just really want to focus at the very gist of the particular functionality and features that has been added since the last part, rather than this typing skills, right? So we need to add we need to import bytes and OS exec. So these two are needed to deal with opening the sed command. I will now explain what is that, how that works, and all this stuff. And the functions that we will add would be the read string function and the execute command. The execute command is the big function down below. So before we proceed with this, let me just show you one little thing. So I just go away from here. And I'm on my Linux terminal now. So if you're on Windows, this is also going to work if you're on Windows, and I will provide the exact instructions on how you can achieve this on Windows, so bear with me. So there is the core Linux utility called sed. It stands for Stream Editor. So what sed can do, it just the rest of the Linux core utilities, and like with the underlying Unix philosophy, it interacts with the standard input and the standard output. What this application allows you to do, it actually allows you to manipulate the text in various ways. So one of the most essential features behind this sed, especially those we're supposed to be using, are find and replace functionality and just search for a certain line. So if I say like sed and then I say so the command I want to provide. So display text buffer, for instance, and so this is the syntax to match the display text buffer. And I'm sorry, just need to specify the file e.go, like this. So it just tells me every time it prints this line where it encounters the display text buffer here and here. But we're only interested in these numbers. So to suppress the output, we need to add here -n. And now we just have these particular lines where the function occurs. So what the execute command is going to be doing, so if in the case if we are in the search mode, we'll pass this output of no matter how many lines there. We'll take the very first line and adjust the current row to the particular number that we extract from here, and that's the exact way how to navigate to the particular line containing the very first occurrence of the display text buffer in this case. So the idea behind the Linux philosophy in general is that you need to write programs that do one thing and do it well. And what I've been thinking about is that instead of like implementing my very own version of sed and making that being embedded into the text editor, I would rather follow the Unix philosophy and use the powerful tool that has been developed for decades, really. And I would just reuse the functionality of that in the Unix sort of style, Unix philosophy style. So what I need to do, I need to invoke sed from within my text editor, and since it's operating on either file streams or the STDIN, STDOUT standard input and output. So I can just essentially what I can do, I can send the byte stream directly to the sed command, and I can retrieve the output from the sed command as well. So, and I can provide that sort of a standard input output interaction from within my text editor with the sed command. So that's the essential thing of what we're supposed to be doing. And then there would be two cases, like how we need to handle the output of the sed command. So sed command might either do output these lines when it just finds occurrence of a single of a given, say, string, or it can also do a very powerful find and replace sort of a job. So let me quickly demonstrate you that. So if I say ego test.txt, for instance, and I just type some gibberish here, but somewhere I say hello and somewhere again I say hello, and somewhere I say hello, for instance, right? And right, quit. So here is our test. So we got a bunch of hellos there. So if I want to replace hellos within the entire file or within the range of lines, it doesn't matter now because it's not a tutorial on how to use sed in particular, although I will say a few words at the very end of the video about that as well. But generally how the sed works. So sed command can be used in order to replace this hellos, say with hi. So if I do like sed, S stands for substitute, literally replace. So replace hello with hi, and I can say globally, but I probably cannot specify it, but just for clarity specify. So globally I want to do this. Yes, and the file name, so test.txt. Yeah, and yeah, it already brings the output. So you see like the hellos has been replaced with highs. Okay, so I just tried to redirect the STDOUT to another file. For some reason it doesn't work with the same file, I don't know why. So let's see what's within the test1.txt. Yeah, and indeed, this file already has all the hellos being substituted with highs. So now imagine if we do exactly the same thing, but instead of interacting via files, we do interact with our text editor's buffer. So instead of reading data from the file, we read the data from the text buffer. And when it comes to updating the output, so literally replacing, performing this final replace job, so we can take the output of the sed command and initialize the content of the text buffer from what we have got in return. So hopefully that makes sense. Now, before we start diving into the source code of how this can be implemented, let's make sure that you guys can run the sed command on Windows, because otherwise this is not going to work. So how to do this? Well, I'm on Linux, so I can't show you exactly the way, but hopefully the explanation would be clear enough and concise enough to follow. So if you download the release or the source code or wherever, you see the sed command, the sed folder, so cd into the sed folder, and there is the executable setup file. You can use this one, or you can download one from internet, or you can build from sources. It's all up to you. So in my case, I use Wine to run this. In your case, you can just click on it and it would just install. So well, obviously I already have this installed, but just to give an idea, so if I run the installer, I can here install this entire thing to the hard drive. So I'm not going to be doing this because I have already this installed. So this has been installed to C program files GNU Win32, but I highly recommend to install it directly into C GNU Win32. I will now explain why. So, well, actually, essentially I've installed this to program files, but then I just manually copy this to C GNU Win. So that works. If I click next, it just goes and install it. But again, I already have this. So yes, exit setup. So let's say wine regedit, so register editor. So it has quite a complicated path. So HK local machine system, current control set, control, then session manager, environment. So here within the environment, I have these path variable, and you see by the very end of this string here we have this semicolon GNU Win32 bin folder being appended. So this has been appended. It wasn't there before. So if you just install it, it's not there yet. So you have this like Windows system 32, all the stuff that you might be having the different values here, but yeah, you make sure that the path variable does contain this path c/GNU Win32/bin. So once this is done, then what you can do is the following. If you go to the command line, so say wine task mgr file new task command line. So now I can say sed, and you see like the sed on Windows is actually working. So I didn't provide any valid command, so it just brings me the help file, but sed is available system-wide. This is absolutely essential to make Ego text editor working with the GNU sed appropriately under Windows. Okay, now that being said, let's actually dive into the source code of this routine execute command. So I say ego e.go, and I go down below here. So when the user is pressing X in the view mode, the execute command is being fired here. So execute command. The first thing to do says rows minus minus. So if I say X, you see like it's like one row less. It just makes some extra space for like the command to enter. And then the actual logic is happening. So yeah, just escape from here for a while, because otherwise I won't be able to show the source code. So the command that we're supposed to be typing in is about to be stored in this command variable. The command loop is the loop that allows user to, so say I type something, if it's not working, it's just not going anywhere, but I'm now within the command loop. So escape is the way to escape from the command loop, or the valid command and enter executes the command and also escapes from the command loop. Okay, so this is sort of a infinite loop. There would be some break loop conditions like in here. So we are creating a key press event, and we're using our get key function just like we did when it was about typing characters within the text buffer. So depending on which key did the user press, we can do the following thing. So if the user has pressed the escape key, we just break out of the command loop and go back to editing, right? And when this happens, so after this big switch statement is over, we need to make sure that we do some cleanups and restore the rows so that it sort of jumps back to these, like the view of the terminal has been restored, but we'll come to that a bit later. So otherwise, if the key enter has been pressed, this means that it assumes that user has completed the command, and this command is about to be now executed. So content, what is the content? Content is essentially the entire rows within the text buffer being turned into a string. So we're literally stringifying the entire text buffer. Then we need to distinguish between two possible opportunities, two possible scenarios. We may either enter the command to search something within the text buffer, and otherwise we want to do some find and replace job. So to distinguish between these two, I'm using the isSearch flag, which is equal to false by default. So by default, it assumes that you are about to be like replacing the, like find and replace sort of a thing, not the searching. But in case if within the command we do encounter the equal sign, this means that we are searching. And well, probably this limits the functionality of sed itself. I don't know, I'm not that like experienced user of sed, to be very honest, but yeah, that's the way I do it within the source code. So if there is the equal sign in the command, that means it's not going to replace anything, it's just going to perform, at least try to perform some search, right? So it tries to perform some search, and yeah, so isSearch flag now equals to true. Now we are creating the operating system command, and here again, like if you don't have sed installed either on your Linux or on your Windows system, it's not going to work. So on Linux, it's like always bad because that's the core utility. Every Linux distribution has it, unless you've created your own one and suppress the sed, but I can hardly imagine that scenario. Yeah, and on Windows, make sure that you install and make it visible system-wide. So you create these command, the command sed, and then the command that is supposed to be executed by the sed command. So the particular whatever you type here. So this is treated to be the command that is turning into the command line argument that we are passing later to the sed command. Now, if the search mode is true, if its search is true, then we need to have the additional command line argument, which is -n, to suppress the output of the sed command, so that we can only output the line numbers of the match occurrences or whatever string we're looking for the further parsing later. Then now we are sending the bytes to the STDIN of the particular command. This is quite neat, right? So bytes, new buffer string, and we are sending the content, which is, you remember, the entire text buffer, the entire information available in our text buffer. So what essentially this does, so by passing this to the STDIN, this is like, so we've been using the input file argument when we've been doing this from the command line, but here there is no file, so we just, so sed also allows you to type something from the keyboard, so literally listening to the STDIN if otherwise the input file has not been specified. So in this case, we just sort of faking whatever goes to the STDIN. We're not typing this manually, we're just passing the content of our text buffer as a string, and well, it's actually been turned to bytes, like as if this was entered from the standard input. And we're pointing the command's standard output to this output, right? Handling the errors. So once we've done our setup, so we know where to get the input bytes from, and we also know that this output would hold whatever response the sed command would produce. Whatever response is going to be stored within this output variable. So after this has been set up, we just run the command. So if it's error, so this might happen that you just type in some gibberish, so we just continue, we're not doing anything, and we just sort of stuck in the loop. So I put some gibberish, enter, nothing happens until I either enter a valid command or press escape to break out of the loop. Then result, creating a result variable, which is going to be the output, which is the bytes buffer type, but now after the STD standard output has been redirected to the output, we can then turn the output to the string. Now this result is already a string containing our text buffer that has been already processed by the sed command. So if the length of result is greater than 0, so it might happen that it's 0, in that case we don't want to do anything, so it's greater than 0, so assuming that we have replaced all the occurrences of a single word, for instance. And yeah, now two scenarios. So if this was the search mode, in this case we just pass the current row, we convert in string to integer, and we're slicing the very first one. You remember there were like 3 rows when we were searching for display text buffer. So this is the list of whatever result is there, and we're just picking up the very first one, and if we want to find next, we just specify a different command which starts from the given line where the first occurrence was available, and then from there to the very end of the document, for instance. So it's not really that comfortable sometimes maybe, but quite pretty minimalist, and still practical to see the list. Yeah. And then we do this current row minus minus. So the idea behind this is because of the way how we count the columns. So it's not starting from index 1, but from index 0. So to make sure that the actual currently highlighted line would match the exact row in the text buffer, and put in the current column to 0, because to avoid the cursor sticking somewhere where it shouldn't be. Right, and otherwise, if this is not the search mode, but this is, by default, this is the replace mode. In that case, we want to read the stream. We'll now go to what the read the stream is doing. So read stream, so we initialize the text buffer to an empty buffer, line number, and then the code is exactly the same as we had in the read file. So yeah, that has been covered already. Yeah, so, and we just use this buffer, like the newly updated buffer, as a string, accepting buffer as a string, and literally populates the buffer with whatever lines are available, and from string it turns into the slices of rows again. And on Windows this might happen that the character return is being occurred, so we just ignore that. Okay, let's drop back to where we were before. Then we want to say that if the current row is greater than the length of the text buffer minus 1, so if we just have the overflow of the current row, we just want to make sure that the current row would be the very last line of the text buffer. So again, this is needed just to avoid any nasty known errors, and current column is equal to 0, exactly the same reasons. And after this, we break the command loop. So here we break the command loop only in case if the sed command was executed successfully. So we also need to make sure that we do properly implement the actual typing. So in case if we have the space key being pressed, we just want to append the space to the command, because space does not produce the character, the ASCII character, just the key code that's specific to the term box library implementation. In case of backspace or backspace 2, which is like different backspace codes for different keyboards, we just do erase the very last character from the command. It's pretty simple and straightforward. Otherwise, if we have the ASCII, so this event, if event character is not equal to 0, which means that we have the ASCII character being typed from the keyboard, so something very similar to what we've been doing when we've been implementing the insert character routine in the previous tutorials. So in this case, command is just being appended with whatever stringified value of the key the user has pressed, like letters, obviously. Then want to print the message. It's exactly the same function that allows you to print a line in the term box screen at the given coordinate. So 0 rows plus 1. So literally I print something. So every time I type something, so this string is being re-rendered from scratch. So just print this again. And if I again if I delete, is also, well, arrow keys are not working, doesn't have that. Features also things like read line functionality is not available. But yeah, the commands are quite pretty simple, so no need for that really, just for the sake of simplicity. Yeah. And yeah, indeed, we do render the entire message. So whatever command variable is holding is being rendered here after we call the print message. Then setting the cursor to the line of the command, and rows plus 1 is the fixed, like the very last row on the screen. So just to make sure that the cursor position gets updated. If we press backspace, it might happen that the previously typed characters not get erased. They do get erased within the command variable, but they're not being erased on the screen actually. So to make sure they are also erased on the screen, then we define the length of the command, and starting from where the command ends, we just populate the rest of the line until the very end of the screen with empty spaces, with white spaces. So that's how we implement this dynamic update for the characters that has been deleted. And finally, we flush the term box so that everything goes to user, and we see everything on the screen. And again, like, since we are done now and we are breaking out of the loop, so the command has been successfully executed, or user pressed escape and anyway it just breaks out of the loop. So rows plus plus restores the screen rows, and this gives this feature. So pressing X, it just jumps up, and escape, it just jumps down back. And this is also done for the sake of simplicity of rendering. So if there is something left there, it just gets overwritten by the status bar, and we are done. Okay, so this is in regards to explanations, and now let's see how this sed command integration is actually working. So I just go away from here and I say build and ego e.go, and I will also show you this on Windows. So let's say I want to find where the display text buffer first occurrence is. So I can say X, and then I say slash display text buffer slash equals. So that's the command to find the occurrence of whatever is available within this slashes, and I press enter, and it drives me to the row 231, exactly where the first occurrence of the display text buffer is. And let's say I want to find the further occurrences. So I say, for instance, so X starting from 232, and up to the end of the document, I want to find the display text buffer occurrences, and it would now find me the next one. Okay, it doesn't accept because I need to put the curly braces here. So display text buffer. It's a bit complicated, but if you get used to the commands, it's really cool. So it goes to line 293, so that's the next occurrence, and so on. So that's how we can find the occurrences. So hopefully that makes sense. So essentially that's all in regards to search. And now to do the search and replace, so just quit from here, and let's make this stats.txt. It's probably something is there already. Yes, this hello example in particular. So let's say I want to replace all the hellos with highs. So I say X to enter the command mode, and S substitute hello with hi, like this, and do we globally. And bang, we get all the hellos being substituted with highs. But yeah, just to make sure that I'm not sticking to Linux all the way along, let's actually drop back to our Windows version. So I say wine task mgr, file, new task, command line. And here I say ego.executable test.txt. So we are in the test here. Yeah, since we didn't yet save this, let's try exactly the same thing. Oh, let's say again, I just say for instance X, and I want to find hello, and then just getting into the work where the first occurrence of hello is. So it just works with the sed command on Windows just like it does on Linux. Let's say I want to again substitute, but let's say not everywhere, but starting from the line from the row 5 to row 7. So 5, 7. Want to substitute the hello with hi and go. Yeah, so see, like these two has been substituted while this still remains there. Okay, now let me show you how the indentation works. So it's quite cool. So let's say you have a block of code here and you want to move it like 4 spaces to the right. So you won't be doing like this, right? That's too long. So the sed commands allow you to deal with this in quite an elegant way. So starting from row 5 to row 8, for instance. So 5, 8, and I want to substitute. So here the regular expressions are coming onto the stage. So I can say from the beginning of the line, I want to say 1, 2, 3, 4 spaces here, and then we got the spaces. And also, you probably remember that I was promising to show you how to input the tab characters using the sed command. So for instance, here I want to put 1 tab character instead of 4 spaces. But before that, let's actually see how can we manipulate this back and forth. So again, 5 to 8. So 5, 8, and substitute. So now we match, say, from the beginning of the line and 2 spaces, and replace them with nothing. So we just did it like this. Cool, huh? Okay, now again 5, 8, substitute substitute from the beginning of the line 2 spaces, but this time I want to replace it with a tab character like this, with a single tab. And you see this green squares represent that this is the tab character. You remember that this editor is not rendering tabs with spaces, because I hate this. I don't really want this. I never use I never use tabs. But the reason for having tabs, for instance, you're making a CMake file, you need to make sure that there is a tab, otherwise the syntax is not going to be working for a make file. So sometimes you may want to have tabs being done like this. But yeah, let's actually again replace this with the 4 spaces, for instance. So I can say 5, 8, substitute from the beginning. Well, actually I can match tab probably. and replace it with 4 spaces like this. Yeah, that's the way to go. So yeah, tabs has been replaced with spaces. Now let's see some other interesting features, like for instance copy pasting, say. So let's go away from here and let's go to e.go. Okay, so for instance, let's start with the simple copy pasting. Well, actually it's worth noting that all those features that we have implemented with our copy paste and cut paste functionality, the line oriented ones. So just to make sure, so let me just push this to the buffer. So say delete and paste. So this works, or copy and paste. So this also may work via the sed command. So for instance, we have the row 6, line 6. Yeah. So I say X and line 6. I want to delete the line, and bang, the line has been deleted. I can delete the range of lines. So for instance, say from row 3 to row 11. So I say 3, 11, delete, and it gets deleted. Okay, let's restore it back. And now, for instance, I want to copy this. Start from row 3 to row 12, right? So I want to put it, say, here, 24. 3 to 12, so 3 to 12. So I use capital H to copy all these strings to the so-called whole buffer. H stands for whole buffer. If you use the lowercase h, it would only copy the single line, but this would aggregate the whole buffer. Then to add a new command, I just first use the semicolon. And here, the row 24, I say G, probably stands for get, I'm not quite sure. And okay, and you see these lines has been copied from its original place to over in here. But this is sort of a copy paste, a bulk copy paste. But you can also do this sort of a cut paste thing. So let's drop back. So just restore it. So from 3 to 12, from 3 to 12, I want hold, and 24 get, and then from 3 to 12, I want to delete, right? And bang. So we just got this imports being cut and pasted from its original place to over in here. I know for some reason it does not work in the reverse order. I have no idea why is this so, but well, it just doesn't work that way. But even with this functionality, it still seems quite a powerful sort of a thing. So we've covered just these very basic sed commands, and probably there are much more. I just didn't explore them yet. But whatever comes to like manipulating the text buffer when a newly updated text buffer version is drawn back by the sed command, or when it comes to searching where the line numbers are retrieved back from the sed command, these sort of scenarios can indeed be held by the Ego text editor. Okay guys, so if you have any issues with the source code within the tutorials, you can always reference the corresponding functions within the main source file. And yeah, because this has been extensively tested, I've written the entire series, the entire tutorial series code I've written within this editor in particular. And I've been developing this along the way also, so yeah. Please reference this main source file to make sure that no typos, bugs or something is out there. So I guess that's it from my side. Thanks for watching the entire series. Thanks for following. I really appreciate this. Please let me know in the commentaries what do you think, and also if you think that either the source code itself, like the product itself, or the educational, the didactic value of the series means at least something to you, feel free to make some donations. And there are 2 ways you can subscribe to my Patreon and send me money via PayPal. And the links to both services are going to be available in the description down below the video, so feel free to use those as well. And I guess this is it from my side in regards to the entire series, so thanks for watching, and I'll catch you up later.